Hi, in this video we are solving another two more problem about a surface area from section 6.6. First one is problem 5. So find the surface area of a given curve revolving around the x-axis. And the curve here is y equal 3x plus 4 on 0 to 6 on the x-axis. Now if you plot the curve, this is just a linear function. So the y-intercept is 4, the slope is 3, so I go up 3, go to the right by 1, and then connecting the line. And then I only focus on 0 to 6 on the x-axis, so from 0 up to 6, all this plane region here is the region that we revolving that around the x-axis. Now the formula for the surface area from A to B, 2 pi, the r of x or the radius, and multiply by the square root of 1 plus f prime square and then dx. Now we know that the radius of this curve to the axis of revolution is just r of x here, which is the value of the f of x function, or r of x is just equal to f of x in this case, and that's equal to 3x plus 4. And then the next step is we want to find out f prime, because we need that in here. F of x is given by the curve, so f prime, the derivative of this one is just 3, and the constant becomes 0. And then I square that because I need it here. So 3 squared give me 9. And then now I can use a formula. 2 pi, I can bring it to the outside of the integral. The r of x is right here, 3x plus 4, the square root of 1 plus f prime of x squared, and that is 9. So I know that this is the square root of 10, which is also a constant, so I bring it to the outside. And then the inside of the integral is just 0 to 6, 3x plus 4, and then dx. And here, we can take the integral using the power rule. Add 1 to the exponent, that's become 2 divided by 2. And then 4 becomes 4x. And then we evaluate the answer from 0 to 6. 2 pi square root of 10 stay outside here. And the next step is that you plug in 6 anywhere you see x, and then subtract 0 anywhere you see x. And do the simplification of that. You should end up with 156, the square root of 10 pi. So this whole thing here becomes 0. And then if you combine this one and then multiply with the outside here, you should end up with 156 and the square root of 10 and pi. The second problem that we talk about in this video is the problem 10 in the textbook. It's also on your in your assignments for section 6.6. So we find the surface area of this curve. This is the radical function on 0 to 5 revolving around the x-axis. So if you plot the curve, you can use the TI graphing to plot the curve, and we only consider this is the radical. This is the curve of the square root of 4x plus 6, but I only consider the value from 0 to 5, which is from here to here. So this plane region, I take the whole thing, I revolving that around the x-axis, and then I find the surface area of the whole object. And here, we use the same formula, 2 pi, the radius from 0 to a, 1 plus f prime of x squared dx. We know that the radius r of x is the distance from the axis of revolution up to the curve. In this case, it's just equal to the value of the function, which is f of x, or which is the curve, the given curve. And then we need the term inside here. I can find the term inside the square root first before I plug in the integral. So f of x is given as square root of 4x plus 6, and the square root means the power of 1/2. And then I can take the derivative f prime bring down 1/2, subtract 1 from that, that's become minus 1/2, and we apply the chain rule, which is another derivative of 4x plus 6. And then we can see this is the negative power, so I can bring it to the bottom part, and then that's become the positive 1/2 or the square root again. And when I take the f prime of 4x plus 6, then I get only 4. So the 4 stay on the top. The 1/2 here stayed at the bottom. And 4 divided by 2 give me 2. And then the square root of 4x plus 6. So now I squared because I need the f prime square. So I take the whole quantity here, I squared. 2 square become 4. The square of the square root is gone. And I add 1 to that. 1 add to f prime square, or 1 add to 4 over 4x plus 6. And we find the LCD is 4x plus 6, combine the two fractions, and you should end up with 4x plus 10 over 4x plus 6. And once now you have everything, you can apply the formula 2 pi, right? So 2 pi. And then let's go from 0 to 5, 0 to 5, because we run on the axis of x 0 to 5. And 1 plus f prime square under the square root. You see that one more term, r of x, which is right here. So plug in r of x. So make sure you plug in r of x to the integral. And then the square root of 1 plus f prime square, which is the term we just found in the last step. Okay. And now, because they are the two square root, you can bring them together and multiply them together under the same square root. And from here, we can do more simplifications. We can see that this term and this term, they cancel out. So only 4x plus 10 under the square root remains inside the integral. And from here, we apply the u substitutions. So let u to be 4x plus 10, the term under the radical. du is 4, and then dx, and so for dx, which is du over 4. And make sure you are changing the u, the x to u. Make sure the limit of the integration also changing from x to u. When x is 0, 0 times 4, 0, plus 10, u equals 10. When x is 5, 5 times 4, 20, 20 plus 10, 30 for u. So the new limit of integration is also going from 10 to 30. Okay, from here. And the radical, this term is now u dx, du over 4, the 2 pi stay in the outside. And then now you can simplify that 2 and 4, they cancel 4 and 2 here. The only 2 stay at the bottom, the pi, with the pi. And the radical of u, the square root of u is just the 1/2 of u du. And using the power rule, we add 1/2 to the top. Sorry, add 1 to 1/2 on the top, and then divide the same thing. And then keep the power 2 on the outside, right? And then evaluate the answer from 10 to 30. And if you do that, all you do now is plug in 30 to anywhere you see u, right? And then subtract 10 to anywhere you see u. And dividing a fraction 3/2 means the same thing with the multiplying by the reciprocal of that. So 2 over 3. 3 over 2 become 2 over 3. The same thing to here. And the last step is we combine the like term together. So let's combine the like term here. We can see that when I factor out the 2, to the outside. Then the inside I have the radical over 3, subtract the radical over 3. The 2, they came to the outside. And then we can cancel out the 2 here. So it give me only the pi. And 30 to the third power, I can rewrite that as what? To the second power. And then multiply with the first power here. So 2 plus 1 give me 3 back. And then 10 to the 3 equal to 10 to the square, multiply to 10. Same thing. The reason I write that way, because now I can bring the 30 square and the radical, it jump to the outside 30. The same thing to 10, jump to the outside. So the remaining 30 and 10, they remain inside under the radical. And then from here, we can do more simplification. 30 divided by 3 give me 10. But 10 divided by 3, we cannot simplify that, so we let that be the same thing. And here, we can see that 30 is equal to the radical of 10 times radical of 3. Because 10 times 3 give me back 30. The reason I split the radical of 30 into 10 and 3, so that I can have the common factor of 10 radical 10, 10 radical 10. They are the like term. So I can pull it to the outside of the brackets. So pi, now I can pull 10 radical 10 to the outside. Then the first term only have radical of 3. The second term, when I pull out 10 radical 10, it only has the 3 at the bottom, so 1/3. And then we can use the LCD as 3, and then subtract the 2 fractions. And finally, I can just pull the 3 to the front, and inside the parentheses here is 3 radical of 3 and minus 1. And that is the simplified version of the answer. Okay, so that's it. That's the 2 questions from section 6.6 about finding the surface area. And thanks for watching.